Hi, welcome to this video. In today's video, I'm going to do a very nice problem of United Kingdom Olympiad. Okay, a function f defined on positive integers, f of 1 equal to 1996. We have the sum of f of k as k goes from 1 to the n equal to n squared multiplied by f of n. Okay, as integer n is strictly superior than 1. Okay. The question calculate f of 1996. Okay, it's not challenged problem, but it has a little trick. Okay, once you find the trick, you will solve it easily. Okay, so if you take a look at the given information, we have only one information given here, which is f of 1 equal to 1996. Okay, once you see this information, so you are going to find the relationship between f of n and f of 1. Okay, that's why he's giving f of 1 equal to 1996. You are going to transfer f of n in terms of f1. Okay, go ahead, pause this video and give hand to this problem. When you worry, come back to see the full solution. Okay, let's get into the solution now. So as you see, you have the sum of f of k as k goes from 1 to the n to n squared f of n, right? So now I'm going to calculate the term n minus 1. Okay, I'm going to evaluate this sequence as k goes from 1 to the n minus 1 to see what's giving us. Okay, which is n minus 1 squared f of n minus 1. Okay, now what I'm going to do now, I'm going to subtract equation number 2 from equation number 1 to see what's the expression. Okay, so 1 minus 2 implies the sum of f of k as k goes from 1 to the n minus this sum f of k as k goes from 1 to the n minus 1. Okay, so f of 1 minus f of 1 is 0, f of 2 minus f of 2 is 0, and all the way down f of n minus 1 minus f of n minus 1 equal to 0. I will have only f of n left from all these terms because we have one more term in this first equation, which is f of n. Okay, so this one equal to f of n. All other terms will be cancelled because there is a difference between these numbers. Okay, so equal to this one, the first equation minus the second equation, which is f of n equal to n squared f of n minus n minus 1 quantity square multiplied by f of n minus 1. Okay, now equivalent, so f of n equal to n squared f of n minus n squared minus n minus 1 quantity square multiplied by f of n minus 1. Okay, I'm going to bring n minus 1 quantity square f of n minus 1 to the other side, and I will bring also f of n to the other side. So I will have n minus 1 quantity square f of n minus 1 equal to this one minus this one, which is n squared multiplied by f of n minus f of n. I'm going to put f of n outside as a multiplier. Okay, I will have f of n, okay, multiplied by n squared minus 1. Okay, now I'm going to divide both terms by n squared minus 1. So I will have f of n, okay, equal to n minus 1 quantity square over this one, which is n squared minus 1 multiplied by f of n minus 1. Okay, this is the first expression that I have. Now I found this expression. If you take a look at here, I'm going to multiply this one, n minus 1 factor n minus 1 over n minus 1 multiplied by n plus 1. Okay, multiplied by f of n minus 1. I'm going to simplify n minus 1 from the numerator and denominator, okay? So I will have f of n. Now I'm going to find out the relationship between terms by calculating the first term, f of 2. If I'm plugging number 2 into this fraction, I will have 2 minus 1, which is 1, over 2 plus 1, which is 3, multiplied by f of 2, multiplied by f of 1. Okay? If I'm going to the second term, which is f of 3, I'm going to plug number 3 here. I will have 3 minus 1 equal to 2, over 3 plus 1, which is 4. Okay? Multiplied by f of 2. The third term, I will have f of 4, which is 4 minus 1, which is 3, 4 plus 1, which is 5, multiplied by f of 3, all the way down to the f of n minus 1 equal to n minus 2 over n, okay, multiplied by f of n minus 2. The last term, I will have f of n equal to n minus 1 over n plus 1 multiplied by f of n minus 1, okay? I'm going to make the product, okay, of these terms. So the first product, I will have f of 2 multiplied by f of 3 multiplied by f of 4 and all the way down equal. I'm moving on to the right side of this equation. I'm going to make another product on the right side of this equation. I'm going to multiply the numbers first. So we'll have 1 over 3 multiplied by 2 over 4 multiplied by 3 over 5 and all the way down until you get the term n minus 2 over n multiplied by the last term n minus 1 over n plus 1, and then multiplied by this output of these points, which is f of 1 multiplied by f of 2 multiplied by f of 3 and all the way down to the f of n minus 2 multiplied by f of n minus 1. What I'm going to do now, I'm going to simplify this expression. If you take a look at the left side of this equation, I'm going to simplify number f of 2 from both sides, f of 3 from both sides, f of 4 is f of 4, okay? So f of, and all the way down to the f of n minus 1 is going to simplify it with f of n minus 1. I'm going to the numbers. So the number 3 will be cancelled out with the number 3. Number 4 will be cancelled out with the number after this one. So number 5 will be cancelled out with the term after this one. So the n minus 1 will be cancelled out as well with the term before this one. And n minus 2 will be cancelled out with the term before this one. So what's left? F of n minus 2 will be cancelled out with the term before this one, which is f of n minus 2. Okay? So what's left now? I will have only f of n left from the left side of this equation. Number 2. Okay? And number f of 1. Over these two terms, n multiplied by n plus 1. Okay? Now I found this expression. Okay? Now f of 1996 equal 2 times multiplied by f of 1, which is 1996, okay, over n, which is 1996, multiply 1996 plus 1, which is 1997. I'm going to cancel out 1996 from numerator and denominator. I will have 2 over 1997. Okay, so this is the result of this one. Now f of 1 equal to 2 over 1997. Okay, I have done with this problem. Thank you for watching. I will see you in next video. Bye.